Hi everyone, how are you? So whoever is there, can you please tell me? So today what we are going to do, it is a practice session on first law of thermodynamics, and I have brought some wonderful questions for you. The questions that you may have never seen, these are not previous year questions. Evening Bhavya, good evening. So these are very new questions and very good questions on first law of thermodynamics. Okay, I have given it enough time to select these questions. Okay, so Kalyan, hello. So again, I welcome you to India's most comprehensive preparation platform for GATE and ESE BYJU'S Exam Prep. Today's session is on first law of thermodynamics. Very wonderful questions I am going to do. I'll give you some homework as well, some 7-8 questions and very nice questions. Okay. Let's give people 1 minute. I'll just do, so there's a free GATE workshop that happens on a rolling basis. You can find the details in the description box, okay, and you can register it there. It's a guidance workshop for GATE aspirants, okay, and there's a rolling scholarship, so it's for, and you can get up to 90% scholarship. So if you are struggling with finances, this is a very nice way to prepare and to enroll with BYJU'S Exam Prep. And this is also a rolling advertisement, so I think every 15 days you will have this. You can find the description, the details in the description box. And finally, we have a free ebook for GATE that you can download from the link. A brief introduction. I have around 4 years of teaching experience. I have, for the people who are first time here, I have done my MTech from IIT Kharagpur. I have done MSc from Politecnico di Milano. I have some industry and research experience as well, some publications. And you will see me taking thermal engineering, basic and applied, and heat and mass transfer on YouTube and BYJU'S Exam Prep. And again, it's very important that you join my Telegram group, because I am going to share the PPT there with the homework, and I'll follow the whatever you will solve in the Telegram group. Okay, so you can share what you have solved, and I can say that if it is correct or not, and we can discuss it there. So it's very important that you join that. Okay, so are you excited? Because I am excited. I have done a very good, collection of questions, and you will feel that when we do the questions. These are not normal questions. So should we start? Ebook kahan hai, sir? You will get in the description box. You will get it there somewhere. This level is used full for XC. This is thermal engineering, right? Okay. Okay, so we will start with some basic questions. I have done a collection for numerical answer type, MSQs and MCQs. Okay, so every type of question we are going to see, I have prepared it according to GATE level only. Okay, so let's start with 2 or 3 basic questions to bring the motivation, and then we will go to very, very good questions. Okay, so, and I need your participation in this. I need your active participation in this, okay, so that we can move forward. I need to solve 18 questions today. I will give you 8 questions, 7 to 8 questions for homework, and 10 to 11 I intend to solve in 1 hour session. We can extend according to the requirement. Okay, so let's start with a basic question. I would say it is a basic question, but it is a GATE level question. Okay, so the expansion process that is happening here, that you can see in this diagram, the total work done by the gas will be. I know you all can solve this. I know that you can solve this. Sir, do for every chapter like this. Yes, we will do this. Today is first law, tomorrow is second law, and then entropy and available energy on Monday. These are all important part. It covers 80 to 90% of your thermodynamics. Okay, and tomorrow also I have given much time that is required, okay, to prepare these questions. So I need your active participation as well, and I hope that you are solving this question. I hope you are solving this. So you see this diagram, right? You see this diagram. So let me write it here. The data. Okay, what is given to you? So we have process A to B. Here pressure is constant. PA is equals to PB is equals to 50 bar. Okay, and VA is equals to 0.2 and VB is equals to 0.4. It is a constant pressure process. And we all know, good evening Madhvi. CS quiz. Solutions are not now available. I am not very sure about CS. I'm really sorry. Okay, so now, and then process B2C. Now this is a constant pressure process. We all know how to calculate work for a constant pressure process. 20.3 bar. Let me check. What is that? PC? Okay, PC, I don't know. You solve for the total work done. I can tell you work done for AB and work done for BC. Okay, so process BC is following PV 1.3 is equals to constant. What do we know here? We know PB is equals to 50 bar. PC I don't know. VB I know, which is 0.4, and VC is 0.8. It is a very basic question and it is a gate level question. We will come to more complicated questions. Okay, we will come with very nice questions that you will actually feel that I have learned something new today. Okay, so let's start this. We have two processes. Total work done is what? Total work done is work done by AB process plus work done by BC process. Okay, and I know that you all know, I already told you in the Telegram group, please revise your first law concept. Heat transfer, work transfer, first law for a cycle, first law for a process. Okay, so we all know this, right? So work done for process A to B is a constant pressure process. So it is P VB minus VA. Do I need to solve this for you? Do I need to work AB is? Work AB is, that is right, 1 megajoule, yes. Okay, that is correct, Bhavya, very nice. Work BC is 1.25 megajoule, that is correct. That is absolutely. I want everyone solving this, really. That is, you need to understand the importance of solving the question. I know that you know this. I know that you know how to calculate work AB. You put pressure here, 50 into 10 to the power 2 kilopascal into 0.4 minus 0.2. You can calculate this. I am not going to waste my time on this because I need to solve some important questions. Okay, it is just for your own benefit. So as you have solved, it is 1000 kilojoule, and work in BC is polytropic process. Polytropic. So what is it? PVBVB minus PCVC upon N minus 1. N minus 1. So do I need to solve this for you, or we can move to important questions? Please solve this, Kiran. Very nice, 2.25 megajoule. That is correct. That is absolutely correct. But in question, it is very important that you read the question carefully. They are asking in kilojoule and it is a numerical type question. If you write it 2.25, it is not correct, isn't it? I know that you have solved it, but with little mistake, with little silly mistake, you got the wrong answer. Because they are not going to see 2.25. The answer is fed as 2253, yes, kilojoule. Okay, it's very important that you read the question very carefully, and especially in numerical answer type. Because if it is a multiple choice question, you see the options and you realize. But in numerical answer type, you need to see in what units they are asking. So it's very important that you solve it in the same units. Okay, so now we need to calculate PC. How can I calculate this? PBVB 1.3 is equals to PC VC 1.3. PC I need to calculate PB VB by VC 1 by 3. Do I need to put the values? I don't think so. I know that you are all capable of doing this, isn't it? So we can put our time to a better use, right? So when you put the values, you calculate PC here. I think Bhavya has calculated earlier. at 20, I am hoping that that is correct, I don't know, 20.3 into 10 to the power 2 kilopascal. You calculated in bar, right? Yes. Okay. So when you put the values here, you will get BC is how much? 1.25. So I can say it is 125.3. This is what? 1253. Okay. 0.3 kilojoule. And then you sum them up. And you will get what you have gotten, 2251. 2251 I am assuming. Okay. 2253 I got. But it's okay, no problem. Kilojoule. Should we move ahead? I need everyone's participation. Madhvi, okay. Okay. Kalyan, Kiran, 2.25 megajoule. Always read the question very carefully. See in what units, because units are very, very, very important. Okay. Now, so this question, the working fluid in a thermodynamic engine cycle undergoes work and heat interaction as given. So we have a cycle. Let's say we have a cycle. I can show the cycle by a circle clockwise rotation. Okay. Let me draw it here. So we have a cycle and I can show like clockwise direction. Now heat and work interaction are happening. So 2 work interaction, 3 heat interaction. How work interaction is happening? So 15 work in is equals to 15 kilojoule and work out is equals to 44 kilojoule. Heat interaction is also happening. How? 70 Q in is equals to 75 kilojoule and Q out is equals to 40 kilojoule. This is happening. And they are saying there is one more heat interaction that is happening. I don't know what direction. So let me assume that there is a Q3 and it is going out. It is from the fluid. It is rejected by the cycle. I am assuming this. Now they are asking, choose the correct option for the magnitude and direction of the third heat transfer. It is a MSQ. So more than one option can be correct. Multiple choice question. More than magnitude is 6. Yes, magnitude is 6. That is correct. But what is the direction? To the fluid or from the fluid? From the fluid. That is correct. Is everyone solving this? There are 15 people I can see here. I need everyone's. Magnitude is 6 kilojoule. Yes, that is correct. And heat interaction is from the fluid. So do I need to solve this for you? So first, I won't solve it. I'll just write the concept. First law of thermodynamics for a cycle. What did we study? First law of thermodynamics for a cycle. It is summation of Q is equals to summation of W. Okay. You can also solve this by simple first law. Energy in is equals to energy out. Whatever is coming in is equals to whatever is coming out. And you know everything. There is only one unknown. You can also do using this or you can use this. So what is Q? So first of all, Q in is positive for me. Q in is positive. Q out is negative, and I am assuming that Q3 is also going out, so minus Q3 is equals to W work going in is negative, so minus W in plus W out. You put all the values, calculate Q3. If this Q3 you get positive, what does it mean? If it is positive, it means it is in the same direction that you have assumed, right? If this Q3 is positive, it does not mean it is given to the system. You have already assumed that it is going out, so you have already taken that sign. Now, if it is coming positive, it simply means it is same as how you have assumed. Okay? It is For a cycle, du is 0. Yes, Bhavya, heat from fluid. Yes, that is correct. A and B is correct. Bhavya, yes, because for a cycle, du is 0, right? It is a property. Yeah, okay. So Q3, if you calculate positive, that means it is in the same direction you are assuming. If it is negative, it means it is in the opposite direction that you have assumed. Okay, so clear, let's move ahead. Let's move ahead to one more simple question and then we'll come to the main question. Okay, so 1.5 kg of liquid having a constant specific heat, mass of liquid is 1.5 kg, C is 2.5 kilojoule per kg Kelvin. Now, should I ask you one question? Heat is out, yes, and 6 kg Deepak, that is correct. So A and B was correct, right? A and B was correct. Okay, let's move ahead. Now, can anyone tell me what C is this? Is it specific heat at constant pressure or specific heat at constant volume? Can anyone tell me what is this C? Very quickly, these are all concepts. Okay, so what is this C? It is specific heat at constant volume or constant pressure. Very quickly tell me. Now what I am doing is, I have a well insulated, I hope that you can see me here, constant volume. Why is it constant volume? Why is it constant volume? That is correct, Bhavya, it is liquid, and Subhadeep, that is correct, both are same. When we talk about solid and liquid, C is always constant. Cp is equals to Cv is equals to C, that's all. When we talk about gas, yeah, that is correct, it is incompressible. That is why I am saying specific heat at constant pressure and constant volume is same for solid and liquid. For gas, they are separate. Cp and Cv are different. So there you need there you may be confused, but if it is liquid, you don't need to worry, sir, it is Cp or Cv, how do I calculate? You don't have to worry. Okay, so we have an insulated chamber here, insulated chamber. Okay, now what I am doing, I have a liquid here, mass is given and its C is given. Now I have a stirrer, so I am stirring it. Okay, and its temperature of what gas is increasing, delta T here is 15 degrees Celsius. Now find the change in energy and work transfer for this process. Find the change in energy. So what is happening? It is a heat addition process. Okay, heat addition. Now some people are confused, sir. You are saying that its temperature is rising, but it is well insulated, and I am saying it is adiabatic. I am saying insulated. Du is equals to plus W, and du is equals to W is equals to negative. You have explained it somehow, but I am not sure if like everyone can C is let me see if C is correct. Du is equals to 56.25, that is correct, and then W is minus 56. Absolutely correct. Very nice. I need this crowd. Because look, I can solve this, but why I need your participation, so that I can solve more questions here, you can get more practice. That is correct. Du is equals to, very quickly I explain the concept and then we will move ahead to one question. Okay, so what is happening here is, this is my chamber, insulated chamber. So as soon as I say insulated, let me explain this. I am giving some work to it, work in. When I am giving this work, so this fluid, the liquid is there, it is getting heated. So whatever liquid is there, its temperature is going to increase to delta T, 15 degrees Celsius. But this is insulated. So no heat interaction between system and surrounding. This Q is equals to 0. So if I say first law of thermodynamics, for a cycle we have seen in the last question. What is for a process? For a process, this is the heat addition process, right? This work is converted into heat, and that is raising the temperature. Okay, so first for a process, what is it? dq is equals to du plus dw, when I am assuming that heat is given, and work it out. Okay. Now it is saying well insulated. That means there is no heat interaction between system and surrounding. Okay. So this is 0. Now du is equals to mc dt. mc dt. Okay. So m I know, c I know, delta t also I know 15 degree. So URI stair is no, stair is not in our system. That is how work is crossing the boundary. That's why we are calculating work. If stair is in our system, then there is no work. If I make this system somehow, that this stair I draw here inside, then it is not in our system. Okay. So, but what is happening, that I need to give some power to it. No, how are you rotating this stair? I need to install a motor, and that motor will be connected to a shaft. That shaft is rotating this stair. So this electrical power is from outside, right? If I draw my chamber like this, that means there is no work transfer. Okay. But work is only there when it crosses the boundary. Abhi ye karo, just be with me, okay? And we will do that also, but not just yet. We will do around the GATE exam, right? There. Abhi if I do marathon, then again you will forget. Okay, let's look. I need to solve many questions today. We will run out of time. That's why I am saying, let's continue the questions, okay? Let's keep our energy there, okay? So let's focus on that, right? Now, du is there. And now from this, so du I can calculate. And from this, what can I write? Du is equals to minus w. And we can see also that work is negative for us. We are giving this work, right? So we can see also this. There is no hunch here. We are not, just we are tukka nahi maar rahe hum. Okay, so we can see that we are giving work. Okay, let's move ahead. Now, one homework question for you. So this is a well insulated chamber. This is a well insulated chamber. But if the same question is for a conducting chamber, if the same question, this is question number 1, homework question number 1. Okay, if this is a conducting chamber, then you have to calculate change in energy and work transfer. And they are saying heat transfer is happening now because it is a conducting chamber. Heat transfer from the liquid to the surrounding is this. Temperature change is still 15 degrees Celsius. Okay. So yes, only that, because look, I am giving you 7 or 8 questions depending upon time homework. So we do not have enough time to discuss it in the class tomorrow. So it's better that you do it on Telegram. Okay. You post a solution there, and we will discuss it there. Okay, everyone, it is for everyone. Okay, so, and these questions are important. That's why I am telling you, please solve them. Okay, it's for your. So now this is the main question. Let's come to this. Let's read this question. What is happening here? We have a piston. And of a closed cylinder. We have a closed cylinder. Okay, let's draw it here. So we have a closed cylinder and there is a piston here. Okay. A closed cylinder of 0.25 meter diameter is retained at a position through a spring and a stopper. So we have a spring here and some stoppers here. Volume on one side, this side volume is contains air. On one side it contains air and 750 kilopascal, right? And the other side it's evacuated. Very good question, I am going to tell you. A lot of concepts are going to come out from this. Okay? And the other side, this side is evacuated. Okay, this side is evacuated. Now at this position, a spring is exerted 120 Newton force on the gas. Okay? Now what we will do? Now stoppers are removed and the piston will go up. Okay. Then when the piston will go up, then it will stop somewhere. It will travel a distance of 1.2 meters. and then it will stop. At this position, now the force is 5 kilonewton, because spring is stressed. Now you see, if this is kx, spring constant, and this force that it is putting, it depends on the value of x. Now the spring is compressed, okay, the piston has gone up, so it is pushing more. It is applying more force, okay. The spring force is linearly increased by the piston displacement to a final value of 5 kilonewton. The force is changing linearly with the distance. So Fx is changing linearly constant, or initial value, that is Fi. That is initial value Fi plus Kx. That is how the force is changing. It is changing linearly. Even if they would not give you, whenever spring is there, so the change, pressure and volume, or force and distance, they are basically same thing. You see, first of all, the work done by the compressed air on the piston in kilojoule. Because what is happening? Because of the gas that is here, as soon as you have removed the piston, remove the stoppers, this gas is going to do some work. Because of this gas pressure, it is going to expand, and it is going to push the piston upward, okay. F spring is one force in spring case is 2.44. I am not sure, let me see. I don't know, I'm not sure that is the correct spring force. Okay, you are calculating force of spring case 1, 2, you have changed into pressure, right? Force you are saying, and you have written the units of pressure. We are not going to change it in pressure, okay, because we do not know the area also here. This height we do not know, okay. Let's try to understand this one more time. Now see what is happening here. Work done you calculate by pressure into dV, right? That is the basic thing. And how do we start? We start with work is equals to force into dx, right? And these units are joule and joule. So we can convert this also, right? If we take this, work is equals to force into area, right? Isn't it? So can we write force upon area into dV? And that comes to be force into dx, okay. So these formulas are interchangeable. Right? Similarly, we can also see for a PV diagram. If I draw a PV diagram, I hope that is visible to you. So PV diagram, what do we do? Whenever 3.7 kilojoule, just 1 second. 3.7 is not correct. I think you are close, but not 3.07. That is absolutely correct. Very nice. Very nice. Okay. So now just let me explain the concept. Okay. So if we know P1 and P2, we know P1 V1 and P2 V2, then we can draw it like this, and we can calculate the area under the curve, right? Same thing we can do by, if we divide it by area and divide this by area. So this is force and this is the distance that it has traveled. Okay. So we can draw this on force and distance diagram as well. So let's do that. Okay. So let's do it here. Now F1. What is F1? So F1 is force into X. F1 is 120 Newton and F2 is 5000 Newton. And it is changing linearly. So, and X, if we are assuming initial value of X is 0, X1 is equals to 0, X2 is equals to, it has moved 1.2 meters. It has moved 1.2. So this is my initial value. This is my final value. I hope you can solve this now. You see, work done is equals to area under the curve. How is it? 1/2 F1 plus F2 and X2 minus X1, isn't it? So you can get this. I know that you will find this 1 upon 2, 120 plus 5000 and 1.2. So if you solve this, you will find 3.072 kilojoule. Very nice. That is absolutely correct. There is one more way of doing it. So work done is equals to F into dx. Now we all know, just for the concept I am going to tell you, okay? Now we know that force is changing linearly. Force is changing linearly, okay? Fx is equals to initial value, whatever is initial value, 120, plus kx, spring constant and the distance, okay? Now this is 5000, this is 120, plus k, this is 1.2. So you can find k here and you can write it fx is equals to 120 plus k, whatever value you get, and x. And then I can put it here 120 plus kx dx. Now I know this k. So now I can integrate this from 0 to 1.2. So try this also, you will get the same answer. If you try this, you will get the same answer. Okay? Is this okay? Can you tell me, is this okay? Then we'll move ahead. K is equals to 4066. I think that is, yeah, 4067. That is correct. That is correct. Okay? So you put K here, 120, 4067 x, and then you can integrate this. Only x is there, right? You can integrate this 120x plus 4067 x square by 2, and you can put 0 to 1.2 and you can solve this. Pressure is basically telling you that, look, there is a way that you can calculate with pressure as well. Okay, but then you have to calculate pressure at 1 and 2 both. And I am not sure because this height is not known to you. And I need to find this area as well, okay, because pressure is equals to force per unit area. Now 120 upon area is pi by 4, d square. Okay, yeah, maybe you can find this as well, but I'm sorry, this, okay. You can try this as well, but I have not tried this way as well, okay. You see what is P1, and then you can find out P2 as well, 5 kilonewton. So from that also you can try, okay. So these are different ways of doing it, but I have not tried it this way. See if it comes there, okay. Let's move ahead with the next question, okay. So fifth, now this question. This is the same question. Whenever spring-loaded piston is there, so even if they do not tell you, you see what is happening. We have a spring-loaded piston cylinder device that contains 5 kg of helium. So mass is 5 kg. Now when you heat this, the pressure is changing. P1 is equals to 100 kilopascal and T1 is equals to 20 degrees Celsius. P2 is equals to 800 kilopascal and T2 is equals to 160 degrees Celsius. Now I need to find out heat and work interaction. How do I find out work interaction? As soon as they tell you that it is a spring-loaded piston, you see, you have given this, you can find out V1 and V2, isn't it? Because R and CV is also, R is also given. So V1 is equals to MRT1 upon P1. So you can find out this. And similarly, you can find out V2. Now I know P1, I know V1, I know P2, I know V2. As they have given you a spring-loaded piston, ये सब क्या है, क्या काम आता है? Okay, very nice. Okay, Okay, anyway, let's move ahead. Let's, rise above this. So as soon as you see a spring-loaded piston, you know that pressure and volume are linearly related. Okay, so you can draw P1, you can draw P2, you can draw V1, you can draw V2, and you can join them, and you know that they are linearly related. I am sorry. Okay. So as soon as you see spring-loaded piston means pressure and volume are, because in order to draw PV diagram, you must know how pressure and volume are related. Okay. Now they have not given you pressure volume, how they are related, but because they have given spring-loaded piston, so you know that they are linearly related. Okay. Is this helpful for you or not? So you can calculate work done. Work done is equals to 1 upon 2. Okay, this is homework. This is homework. Okay, so you can try this as well. Write question number 2. Easy, isn't it? Now next question. The fluid in a frictionless piston cylinder arrangement of 0.4 meter diameter is stirred in a, so what do we have? We have a piston cylinder arrangement. Its diameter is 0.4 meter. Now there is a stair, and so it is attached with a motor, right? And it is rotated at 850 rpm, 850 rpm for 10 minutes, for 10 minutes. Now because this work that has been done by the stair, the piston has moved. The piston has moved to a distance of 0.485 against the atmosphere. Against the atmosphere. Net work done they are giving 2 kilojoule. Net work done is 2 kilojoule. Find this steering power motor, power of this motor, and shaft torque. Shaft torque. Okay. So what is happening here? How do you calculate this? Fun with whoever is this person. Okay, so could you please do that marketing somewhere else? Okay. Anyway, so what is happening here? Now this stair work we are giving, and because of this, this piston is moving against the atmosphere. Against the atmosphere. Okay. So what will happen? Now when this gas, so what is happening? Some Q is given to this. What is there? A fluid is there, and because of this heat, the internal energy of this fluid is going to increase, and it is going to push the piston upward. Now the pressure will remain same. Pressure will remain same. Okay. The pressure will remain same. It will be atmospheric pressure, because the piston is only moving against atmospheric pressure. Okay. So can you calculate steering motor power and shaft torque? Now first of all, they are giving net work done by the fluid. So net work done will be equal to work output minus work input. Now what is this work output? This work output is basically work done by the piston, because piston is going up. So system is doing the work, and work in is basically steer work. Steer work. Okay. Now how do you calculate work done by the piston? How do you calculate work done by the piston? So it is a constant pressure work. It is a constant pressure work. So P atmosphere dV, isn't it? And how 101.325 kilopascal. One second. Work done by piston is equals to P atmosphere and dV 101.325 kilopascal. And how do you calculate dV? How do you calculate dV? Area into x. Yes, that is correct. So this is pi by 4 d square, 0.4 square into the distance that the piston has traveled, 0.485. So can you tell me what is the work done by the piston? Work done by the piston, how much is it? Have you calculated? 6.175. Let me check. Okay, this is 6.175, absolutely correct. 6.175 kilojoule. Now they are saying net work is 2 kilojoule. So can you calculate how much work is given by the steer? Net work done by the system is 2 kilojoule, isn't it? So 2 kilojoule is equals to 6.175 plus minus work input. So can you tell me how much is this work input? Is 4, how much is this? 4 point something, right? 4.175. Now this work is given by the steer. And how the steer is giving? Because I have installed a motor there. This motor is giving this work. So can I calculate the power of that motor? Yes, I can, of course. What is the power? What is the power of that motor? Power of this motor will be work done by steer upon time, isn't it? Kilojoule per second is kilowatt power, isn't it? So very quickly tell me, kilowatt is 371. Let me check. Motor power. How like that is not correct. 6.96 watt is correct. 6.96 watt is correct. You have to calculate this in watt. Subhadeep, what are you doing wrong? Why this value has come? What was wrong? 6 points. So this is given in minutes. You need to divide it, multiply it by 60. Okay. So work done is 4.175 into 10 to the power 3. I'll move just 1 second. 10 into 60. So if you calculate this, you will get 6.96 watt. Did you get it, Subhadeep? Did you get it or not? You must get it, okay? Or you were doing something wrong. That is correct. Okay? So 6.96, or either B and C is correct. Then what about torque? How do you calculate torque? So power is equals to torque into omega. Yes, very nice. So torque is equals to 6 point, which is power, 1 second. Torque is equals to power upon omega. Power is equals to 6.96 as you have calculated upon 2 pi n by 60. Okay? So 60 will come here. So I hope you will calculate torque. How much is torque? Repeat. Okay, what do you want me to repeat? Just 1 second. Okay? So look, what is happening? We have a piston cylinder arrangement. Okay. This one, right? This one, isn't it? That is okay. Who is asking repeat? Please repeat. Deepak. Which question? This question, right? Last question, which one? It is the same question, which torque I calculated. Okay. So what is happening here is I have a piston cylinder arrangement. Okay. Now the piston is flexible. Piston can move. Now I have installed a steer, and that steer is run by a motor. Because if I have to rotate something, I need to install a motor, right? I cannot manually do it. I can do it, but it's not, I cannot do it to raise the temperature. Okay. So I have a motor that is rotating a steer. Because of this steer, the internal energy of the system is increasing, and then it is pushing the piston up. Now it is saying the net work done. Net work done means what? The work that is out. So work out is what? The piston, when piston is moving, it is doing some work, that is work output, minus the work input. What is work input? The steer, that is work that we have to give to the steer. Okay, so work output we can calculate like this, because this piston is moving at with a constant pressure. It is moving against the constant pressure, which is atmospheric. There is no other pressure. So P atmospheric into delta V. What is delta V? Delta V is area of the piston into the height that it is capturing, the height that it is moved. So this is what we have. This is delta V. What is the constant pressure work? Pressure into delta V, isn't it? So delta V is area into the difference in the distance that has traveled. Okay, so this is the work done by the piston. Now if you put this, net work done is given to you 2 kilojoule. Work output we have calculated, which is piston. So I'll calculate work input. Now this work input is the work that is given by the motor or the steer. So when they are asking, then find steering motor power, then they are asking find steering motor power, this simply means that I need to take this work, steer work. Work input by the steer. So work input by time. Power is what? Work by time. Rate of doing work. Okay, so this is how we have calculated power. Once power we have calculated, so power is equals to torque into omega, and torque we can calculate. Is this okay, Deepak? Can we move ahead? 7th question, we are on 7th question. Is this okay? Then we can move ahead. Deepak, can you please give us good to go? They are saying that piston is slowly moving a distance of 0.485 against the atmosphere. So only pressure that the piston has to resist is atmospheric pressure. That is why it is happening at atmospheric pressure only. Is this okay? That is why we have taken atmospheric pressure. Can you tell me, is this okay? Then let's move ahead. Okay, one more question. For a two-cylinder IC engine, air enters at 101.325 kilopascal. So we have a IC engine. So what is happening? Air is entering at 101.325 kilopascal. Air is entering at, so pressure 1 is 101.325 kilopascal. Now the air is compressed. The air is compressed to 1/5 of its initial volume. So when air is entered, for example, piston was here earlier. I hope you can see it. When air is entered, the piston has moved in this direction. So now the piston has reached here. Now the piston has reached here on pressure is P1. Is this okay? When the piston is moved, P2 is 700 kilopascal. What is P2? Okay. P2 must be, just 1 second, let me see. Yeah, that is 699, that is correct. Okay, just give me some time to explain the question. Okay, so what is happening here? Air is coming, piston has moved. Now what are we doing? We are doing compression work in. This is the compression process. Now when I am compressing it, I have moved the piston here. And this distance during compression stroke is 0.25 meter. This is 0.25 meter. Okay, and they are saying V1 is the initial volume and V2 is V1 by 5. Final volume is, so the air is compressed to 1/5 of the initial volume, as this is the process of how it is happening. The bore diameter is also given 0.15, okay, and 0.25 is the compression stroke. When each cylinder undergoes 50 compression strokes per minute, the power input in kilowatt I need to find. Now we know it is a polytropic compression process. We know it is a polytropic compression process. So what can I write? Work done per cylinder. There are 2 cylinders, right? And per stroke is equals to P1 V1 minus P2 V2 upon n minus 1, right? This is how it is happening. So now P1 I know, P1 is equals to 101.325 kilopascal. How do I calculate P2? I know that P1 V1 1.2 is equals to P2 V2 1.2. So P2 is equals to P1 V1 by V2 1.2. And also I know this that V2 is equals to V1 by 5. That means V1 by V2 is equals to 5. So can I put 5 here, and P1 I know, I can find out P2, which Bhavya has calculated to be 700 kilopascal. So I know P1, I know P2, but I do not know V1 and V2. How do I calculate V1 and V2? Is anyone doing it with me? How do you calculate V1 and V2? So look, they have given compression stroke. So what does it mean? When piston moved from here to here, there is a change in volume. So that change in volume, I should write it here. dV is equals to V1 minus V2. Okay, now what is this dV? It is pi by 4 d square into dx. Okay, it is area into dx. dx is how much? 0.25. Now this is V1 minus V1 by 5. V1 by 5. V2 is what? V1 by 5. Isn't it? So can you calculate V1? Can you calculate V1 here? dV, I don't know dV, I'm sorry. You just calculate V1. How much is V1? V1 and V2. Once you know V1, you can calculate V2 as well. Yes, that is correct. Pi by 4 d square into the distance that the piston has traveled. That is correct. Okay, nice. So V1, you tell me how much is V1? V1 is, that is correct. V1 is equals to 0.00552. No, look, first of all, if clearance volume is not given, whenever you do even IC engines, no, there are 2 volumes that we do. When we analyze this, one is without clearance, one is with clearance, okay? So if in question they have not given, you will not assume that clearance volume is there, first of all. The second thing is there, they have clearly mentioned compression stroke, during compression stroke. If it is normal stroke, then it goes from TDC to BDC, okay? If it is a normal stroke, then it will go from this point, from this point to this, isn't it? That is your normal stroke. But they have given compression stroke. So during compression, it will move from some point to the other point. Okay. Arihant, is this okay? Do you understand this? They have clearly mentioned compression stroke. That means during compression, it is moving this distance. Yes. So now you know V1, you know V2 as well. V2 is equals to V1 by 5. Now what is the matter? You can calculate work. Work is minus 1.06. 1.053, I think that is correct. So work done per cylinder is equals to minus 1.06 0.053 as you have calculated, and it is in kilojoule. Now we have two cylinders. And there are 500 compression strokes per minute, and we need to find out power. So work done as you have calculated is minus 1.053 kilojoule. Now this is kilojoule per cylinder and per stroke. Okay, so number of cylinders are 2 cylinders, and into 500 strokes per minute. So per stroke this will cancel, cylinder will cancel, into 1/60 seconds per minute. And that is correct. That is minus 17.7 kilowatt. That is absolutely correct. If you solve this, minus 17.7, okay, 7, I guess, kilowatt. Is this clear? Is this clear? Should we move ahead to the next question? Question number 9 is homework for you. Question number 9 is homework for you. They are saying pressure and volume are related like this. Now this is a real gas. This is a real gas. Okay, so pressure and normally for our ideal gas it is PV is equals to mRT. But it is some other gas, pressure and volume is related like this. And A is given, B is given, R is given, and it is a isothermal expansion process. So temperature remains constant. Mass is also given. V1 and V2 is given. Now we need to find out the work done. So work done will be equal to P dV. So it is V1, V2. Now pressure relationship I know with volume, isn't it? So it is P plus A by V square, V minus B is equals to constant, because M is constant, R is constant, and T is also constant. Isothermal process. Yes, that is correct. This is a van der Waals equation. Okay. So now you can take out pressure from here in terms of C, V, A and B, and you put it here, and then you integrate it, and you will find out the work done. Do this, it is a homework. Okay. Let's move ahead. Telegram group. Okay. So let's move ahead to the next question. Okay. This is also a homework for you. 8 kg of gas. I am not going to read this. We are running out of time. This is also question number 4 homework. Okay. This is question number 4 homework. I'll share the PPT. Do not worry about it. I'll share the PPT in the Telegram group. If anyone does not know my Telegram group, it is Mechanical by Vipin Yadav. Okay. So these are all very good questions. Okay. It requires concept beyond conventional things that you have learned. Something new you will get in every question. Okay. So now this is a question. A hypothetical engine with 1 kg of gas, 1 kg of gas I have missed here, can be represented as a circle on the PV diagram. So if we have a PV diagram here, so this engine PV diagram, this engine can be represented as a circle with a diameter of 10 centimeter, such that 1 centimeter is equals to 300 kilopascal, and 1 centimeter is also equal to 0.1 meter cube per kg. Heat rejected is also given. Calculate the work done in kilojoule per kg for a cycle and thermal efficiency. Can you calculate the work done in kilojoule per kg? So what do we know? We know that area within the cycle on a PV curve gives you work done. So work done is equals to area under the cycle. So can I calculate what is this? It is a circle. Can I calculate the area? It is pi by 4 d square, so 10 square. So it will be how much? It will be how much? Please repeat your group name. It is mechanical by Vipin Yadav. In the end of the PPT, I will show you as well. Okay, it is mechanical, whole mechanical by Vipin Yadav. At the end of the session, I will show you as well. Okay, okay. So what is this? It is kilojoule per kg. You are saying. Let me check. 2356. That is correct. And thermal efficiency is 70%. That is correct. That is absolutely correct. Okay. So area is, you will see this area 78.5 centimeter square. But I want in kilojoule per kg. How do I do that? 78.5 centimeter into 300 kilopascal per centimeter into 0.1 meter cube per kg and centimeter. So this centimeter square will go, and it is kilopascal into meter cube per kg. Okay, so this is in now kilojoule per kg. Whatever you are getting is 23, I think 2355 I got anyway, 55 kilojoule per kg. And then heat rejected is given. Heat rejected is given. So for a cycle, so now this is Q1 which is given. Work I have calculated, and this is Q2 is given. So Q1 is equals to work done plus Q2. Simple. And efficiency will be equal to work done by Q1. So aren't these the good question? Can you please tell me, have you done these kind of questions? Because each question is important. It gives you a new concept. Can you tell me, have you solved these questions before? Look, concept will remain same. Everything you have already learned. Some of them, yes, okay, I mean, I didn't make these questions. For sure, I have taken it from a book. Okay, I have modified in an understanding language. But yes, I mean, but it is above normal questions that you usually solve. Okay, every question basically brings out a new concept, isn't it? It, like, you have to put extra effort on your mind to solve these questions, and this is important because if you keep solving the same questions again and again, you are not going to learn anything new. Okay, so now I hope you will be able to calculate this 0.7. Okay, now this is 11th only, so we have got what? 2355 and 0.723. This is the C is the right option. Okay, I don't care much about options because options I have only made it, but you need to know that how to solve the question. Okay, 11th is done. Now again, this is a very simple question. We have solved it many times. Okay, 3 processes are given. You have to draw a PV diagram and you need to calculate work done and heat transfer. And you all have done it, but these types of questions are asked in exam, so please repeat this question. It is a homework question 5. Okay, because doing, yeah, I know this is a repeat question. I know it is a similar question, but we have to do it. There is no other option. Okay, because these types of questions are asked in the exam. If I am solving 18 questions, I must bring some questions that are repeatedly asked. Okay, so that's why I have kept it in the homework. You need to do it. If I solve this, there is no use. Okay, so please solve this. Telegram group. Okay, anyway, next question. Now we have come to open system. Question number 13, 14, 15, 16, 17, 18. And I think 2 are homework, so we will solve 4 more questions. I think we will end this session before 10. Okay, so we have a steady flow turbine. Very simple question. We have a steady flow turbine. So turbine we draw like this, and everything comes at H1 is equals to, H1 is given, velocity is given, elevation Z1 is given. It is leaving at H2 is given, V2 is given, and Z2 is 0. Heat is also lost. Heat is also lost. Q is lost at 0.29 kilojoule per second. I don't know if you are able to see this. So Q is equals to 0.29 kilojoule per second. Now if the steam flow rate is, so m dot here is 0.42 kilojoule per second. So we need to calculate power output. Very simple question, but open system questions are simple. You cannot do anything about it. You pick up any question from GATE, previous year question, they are fairly, steady flow questions are fairly simple. Okay. In fact, most of the times even velocity and elevation is also not there. So very simple. So we need to apply steady whenever turbine, compressor, heat exchanger, diffuser, nozzle, whatever comes, apply steady flow energy equation. Very quickly tell me what is the power output. Steady flow energy equation, m dot H1 plus V1 square by 2000, because H1 is given in kilojoule per kg, so 2000 I need to put. A is the right answer. Let me check. A is the right answer, and A is not the right answer. Okay. I don't know, just check one more time, because plus GZ1 plus Q dot is equals to m dot H2 plus V2 square by 2000 plus GZ2 by 1000. And if work output is here, if work output is there, so work output. So what is happening, Bhavya? That is correct. Arihant, what did you do wrong? Why did you get A? Did you do plus Q? I think you did plus Q, isn't it? It's minus Q because heat is rejected. Neglected V. Velocity, huh? Okay, good. Anyway, nice. That is why we need to solve questions here. That is why, like, there are so many people comes in the session, they do not solve it. They see, okay, I know this, let's move ahead. Okay, because once you do a mistake, you will not repeat it again. Okay, so now I know everything here. Do I need to solve this for you? I know mass flow rate is 0.42. I know H1. I know H1. I know V1 also. G I know 9.81. This also I know, Z1. Then this is minus 0.29 because it is rejected. But in steady state, we have assumed that we are adding heat. That's why it is positive. Okay. Now is equals to, again m dot I know, H2 I know, this is H2, V2 I know, and Z is 0 this time. So this will go to 0. So I can calculate W. Okay. Very simple, right? So let's move ahead. So answer is C. Okay. Let's move ahead. This is the same question. Okay. Now this question. Now we have an oil cooler. Then I'll give you next question for homework. Okay. So we have an oil cooler. So this is my cooler. It is used to cool oil. Now oil is entering at 90 degrees Celsius and leaving at 30 degrees Celsius. Now water is also entering. Water is entering at 25 degrees Celsius and leaving at 70 degrees Celsius. Enthalpy of oil is given. It is changing with temperature as T plus 10.5 into 10 to the power minus 4 T square kilojoule per kg. And oil flow rate is also given 2.78 kg per second. I need to find out water flow rate. M dot I need to find out water. So any idea how to do this? Simple. Energy in is equals to energy out, steady flow, isn't it? So energy in is equals to energy out. What is energy in? Energy in, that is m dot oil in, h oil in. Velocity and elevation we can neglect. Plus m dot water in, h water I. Now heat in heat exchanger, heat transfer is happening here. Heat transfer is happening here, but it is not going out of the system. So Q is 0. There is no Q. Okay, and it is only heat exchanger, so work will also be 0. Okay. Now what is going out? What is going out? So going out is mass of oil exit, H of oil exit, plus mass of water exit, and H of water exit. Simple, right? Now, what is known, what is unknown? Look, this is known, and this we need to find out. Is this known to me? Yes, I can calculate this at the function of T in. Okay, I am hiding this. Okay, so HOI I can calculate this. I can put T in of oil and I can calculate this. Then HO exit, I can put T exit, which is 30 degree, and I can calculate this. 1.59 is what? That is absolutely correct. Very nice. Where were you? Where were you since the starting of the session? Bhavya, are you able to solve this? Arihant, and who is there? Nagaswamy, very nice. Okay, so I can do this, what? Mass of oil HOI minus HOE by H water I minus H water E, isn't it? Is equals to mass of water. I can do this. Solve this very quickly. You have to calculate mass of oil is 2.78. Yes, that is given to you in kilojoule per second. This is given. We need to find out mass of water. Solve this. Bhavya, where have you gone? You just put temperature here, you can calculate HOI. This is exit and inlet, sorry. Okay, anyway, have you solved it, Arihant? Then let's move ahead. Very quickly, let's move ahead. Yes, okay, then the answer is 1.6. Okay, let's move ahead. So, similar question is given for homework. Similar question is given for homework. Read the question and solve this. Okay, Arihant, Nagaswamy, and whoever is there. Okay, similar question is there. Solve this and post the answer in the Telegram group. Okay, and let's come to the final question for today, 16th and 17th. Okay. Okay, anyway, 16th question. Let's come to 16th question. Okay, 15th is given for homework. 16th question. A 2-meter cube rigid insulated tank. Okay, so we have a rigid insulated tank. Volume is 2 meter cube initially contains air at pressure 1 megapascal and specific volume 0.19 meter cube. So specific volume is 0.19 meter cube per kg, and it is connected to a valve supply. It is connected to a valve supply, and it carries air at temperature 400 degrees Celsius. Now when I open the valve, air starts entering, okay, and the pressure P2, so P1 is 1 megapascal and P2 is 2 megapascal. And T2 is also given 300 degrees Celsius. Determine how much mass is entered. So can I first calculate M1 from here? M1 is equals to how much? M1 is equals to V1. So this is 2 upon 0.19 meter cube upon meter cube per kg. So what is M1? Telegram is mechanical by Vipin Yadav. I will also show you at the end of the session. Okay. So what is this? What is M1? What is M1? It is 10.52 kg. 10.52 kg. Okay. Now, can I calculate T1 as well? Can I calculate T1 as well? Also from here, I can calculate M2. How? M2 is equals to P2V2 MR2. P2V2 MR2. So M2 is equals to 2 into 10 to the power 3. V2 will remain same, volume will remain same, 2 meter cube. R is air, so 0.287, and T2 is also given 300. So 300 is how much? $753. M2, how much is M2? How much is M2? M2 you will get 24.24. So very quickly tell me how much mass has entered. How much mass has entered? Can you tell me what is the right option? How much mass is entered? Mass in will be equal to M2 minus M1. How much is entered? 24.21 minus 10.52 is equals to 13.7. That is correct. So C is the right option. Okay. Let's do one more question, and the last question is for 17th. 16th we have done. C is the right answer. Let's do 17th, and then we will 18th is for homework. Last question. Okay. 17th question. Now what is happening? A piston cylinder device. Look, last one was the rigid container. Now this we have okay. This we have a piston cylinder arrangement, and we have a piston here. Okay. Now initially it contains M1 is 0.6 kg and initial volume is 0.1 meter cube. And the mass of the piston is such that it will maintain a constant pressure of 800. So P1 is also 800 kilopascal. Now this cylinder is connected with a supply line. Okay. And it carries air at 5 megapascal and 500 degrees Celsius. Now the air is allowed slowly into the cylinder until the volume doubles. So V2 is how much? 0.2 meter cube, twice of V1, isn't it? And the temperature T2 reaches 250 degrees Celsius, 250 degrees Celsius. Now, at this point, the valve is closed. Determine the mass of air entered and the amount of heat transfer. Now look, this is a flexible piston, so piston can also move. Okay, so if I write my equation here, unsteady flow energy equation, how will I write? Mass in H in plus Q in heat transfer that is happening is equals to mass out. I can write here, but there is no mass that is going out. Mass out, H out I can write, but there is no mass going out, so this is 0. So I do not need to write this. Then final U M2 U2 minus M1 U1 plus work, if any work is there. But there is a work because the piston is moving up. Okay, so I can write work of piston is pressure V2 minus V1. How much is pressure? Pressure is 800 kilopascal. That remains constant when the piston moves. And V2 minus V1. So V2 is twice of V1. So 2V1 minus V1. Okay. So when you solve this, and V1 is 0.1. So how much is this? Work of piston is, just 1 second. Work of piston is 80 kilojoule. 80 kilojoule, not 800. Okay. It is 0.1. How much is this, Aryant? 800 or 80? Yeah, 80 kilojoule, right? Okay, 800 was the pressure, yes. Pressure remains constant. So now work done is known to me. So can I calculate this? Yes, I can, of course. Q in. First of all, I need to find out M1, M2 and M in. Mass of air entered. So M1 I know, right? How can I calculate M2? M2 will be equal to P2V2 upon RT2. Okay. Pressure is known to me, 800 kilopascal. V2 is 0.2. R is 0.287 because it is air, and 250 convert this into 523. Okay. So M2 you will get, and you can get how much mass is entered. Mass in will be equal to M2 minus M1. How much is M2? Yeah, in question it is saying that the mass of piston is such that it will keep a constant pressure. So it will move in such a way that the pressure inside the cylinder will remain constant. So P2 is also 800. Okay. It is saying it maintains a constant pressure of 800 kilopascal. Okay. So M in now you know. So M in you can keep here. Cp we know for air, and T in is also we know, plus Q in is equals to M2 we have calculated, Cv T2 we know, minus M2 Cv T1 also we know. T1 we need to calculate, okay, plus 80. So T1 also we can calculate from here, T1 is equals to P1 V1 upon MR. Now everything is known to me. Everything is known to me. M in is known to me here. Cp is 1.005. T in is 500 degrees Celsius. Convert this into Kelvin before you put this. Okay. Q in I need to calculate. Okay. M2. This is M2 which we have calculated. Cv is 0.718. T2 is 250. So which is 523 Kelvin. Minus M2. Again I know. Cv I know. T1 I have calculated here. Plus 80. So very quickly tell me how much is Q in. Very quickly tell me how much is Q in. Q in is how much? Okay, I'll give the answer, and then it is minus 81.8 kilojoule. Okay, so it is mass entered is how much? 0.466 kg. So mass entered is 0.466 kg and heat transfer is minus 81.8. Okay. So I hope you had a good practice today. Take the last question. This is 17th only which we just solved. And this is your last question, homework number 7. Okay. So are we good? Are we good? This is my Telegram channel, Mechanical by Vipin Yadav. Okay. So join the Telegram channel. I'll post the PPT there, solve these questions, put your solutions there. If you have any problem, we will discuss it there. Because I cannot come again and I can solve these questions. We will solve questions on second law again, very good questions. Okay. So now let me end this session here, and I hope you had some good practice today. My aim was practice, okay. That's why I was going a little faster, because I am assuming that you know the basics. Okay. So let's meet tomorrow same time 8:30 p.m. and we will do a practice session on second law of thermodynamics. Okay. Okay then. Thank you very much. Thank you for being there for the whole session. Okay. Bye bye. See you tomorrow.